to another node. Okay? So, that's all of the properties of a tree. Okay? So, let's have a test kung naintindihan niyo pa talaga yun. Is this a tree? Bakit hindi siya tree? Point natin kung nasaan yung nagbe-break ng definition. Nasaan yung nagbe-break ng definition? Ay, yung node na yun, di ba? That node. Because that node has two parents. So, also, in a tree, there should be only one path from one node to any other node. Kaso dito, there is something called a cycle. There is a closed loop in this structure. So this is not a tree. So ano kaya tawag dito? If this is not a tree, ano siya? So, this thing is called a graph. Okay? Kapag na-violate yung ibang definitions of a tree, they become a graph. So this is an example of a graph. Okay? So in part 3 of this course, we'll tackle more on graphs, but for now, we will focus on trees. Specifically, what I'm going to show you is what we call a binary search tree. So a binary search tree is like a normal tree. Pero, it has some extra components. Firstly, yung binary search tree natin, kailangan may root node. Kailangan may node na walang parent. Kailangan may mother. All mother, kumbaga. Okay? Tapos, lahat ng nodes na less than the parent node na pupunta sa isang side. So, yung example na to, lahat ng nodes na less than the parent node na pupunta sa left side. Pero pwedeng mapunta din sila sa right side. Okay? No problem yon. Tapos, lahat ng other side, doon na pupunta yung greater than parent node. Okay? Yan yung organization yan. And again, interchangeable yon. Basta isang side less than, isang side greater than the parent node. Okay? Any questions on this? Easy property naman, binary search tree. Also note that sa binary search tree, every node has at most 2 children. Every node has at most 2 children. That's what makes it binary. Okay? So, let's explore a bit of the properties of trees. So, the first property we have is called the level or depth. Okay? The level or depth of a node. Tapos, in this level, para siyang array. Yung root node natin, siya yung level 0. Okay? The root node is always level 0. Then, all of the children of the root node, sila yung level 1. Tapos, all of the children of those children, siya yung level 2. And so on, and so forth. Okay? So, yung root node nasa level 0, yung children niya level 1, then so on and so forth. Okay? Tapos, yung next property as a result of this level or depth is the height of the tree. So, yung height ng tree, siya yung maximum depth. Okay? So, in this example, yung height ng tree na to is 4 kasi may nodes ka at level 4 and there are no nodes beyond level 4. Okay? So, any questions on this? Any questions on this? Okay? Ngayon, how do we create or how do we handle itong mga binary search trees na to? So, to present this, I'd like to use a website called Visualgo. Kasi dito sa website na to, interactive yung pag-create niya ng mga trees and animated pa siya. So I'll make use of this site. Sana may net. Copy. Ay, wrong Wi-Fi. Ano yung minute? Ano yung minute? Wi-Fi at yung hindi gumagana. Okay. Yan. Pangit ng zoom. Need to zoom less. Okay. Kita ba? Okay. So, ngayon, let's proceed to creating a tree. Sa tingin nyo, conceptually, how do you create a tree na walang laman? How do you create a tree na walang laman? The idea is, if you want to create an empty tree, you do absolutely nothing. Okay? Kasi it's empty, di ba? What do you put? What do you place? What code do you implement? Nothing. To create an empty tree, you do nothing. Okay? So, from nothing, how do we add items to this tree? So, how do we insert? So, let's insert an item. Let's insert the number 17. Ano kaya yung mangyayari dito? Okay? So, yung mangyayari dito is, once you insert your first element, the first element will be the root node of your tree. Okay? So, if I insert 17, makikreate yung vertex na yon. So, yung pseudocode nun is, you're gonna look for an insertion point. So, in this case, insertion point nyo is yung root node. So, once you find that insertion point, you create a new vertex. Okay? Tapos, if the point you're looking at, or the node you're looking at, already has content, you check the value to be inserted. Is it less than or greater than the current node that you're looking at? If it's less than, you go to the left. If it's greater than, you go to the right subtree. Okay? So, let's insert another item. Yan, 8 kunwari. So, saan mapupunta si 8? It will go to the left, right? Kasi, makikita niya yung 17. Uy, the root node slot has already been taken. I need to compare my value to the value na nandoon dun sa node na yon. So, makikita ko na, oh, I'm less than 17. I need to go left. When I go left, makikita ko na, uy, there's space. Since there's space, pupunta ako doon. Okay? Let's insert another item, like 12. Saan mapupunta kaya yung 12? So first, pupunta siya sa 17. Makikita niya, uy, may 17 na. Tapos, uy, I'm less than 17. I need to go left. Tapos makikita ko, uy, may 8 doon. Am I less than or greater than 8? I'm greater than 8. So I need to go to the right of 8. So, yun yung dapat gawin ito. Ayan. Okay? So yung 12, napunta siya doon sa middle of the 8 and 17. Okay? So, that's how you perform insertions sa isang tree. Are there any questions on this? In insertions? Yes. In code, how do you know if there's something filling that space? Let's tackle that a bit later. Okay? So, let's just create a random tree or a balanced example. Ayan. For demonstration purposes. Now, how do we remove a node from this tree? To remove a node from this tree, ang gagawin niya lang ay specify mo yung gusto mong value na i-remove. Let's say I want to remove 72. How do I remove 72 kaya? The first thing I need to do is find 72. So, i-check ko muna yung root node. Tapos, in a similar fashion sa insert, I traverse left kung less than, I traverse right kung greater than. Until mahanap ko yung node na gusto kong i-delete. Pag nahanap ko siya, I delete that node. Otherwise, pag di ko siya nahanap, I just stop. Okay? I don't do anything. So, pag nandun ka na sa tamang location, delete mo siya. Otherwise, hindi. Okay? Pero paano kung ma-delete natin yung isang node na nasa middle of the tree? Hindi leaf node yung i-delete natin. Let's say, let's delete 65. Ano kaya ang mangyayari? So, what will happen is something like this. Okay? If you delete a node in the middle of the tree, you need to reorganize somehow while retaining yung binary tree property niya. Okay? That's the idea. Okay? So, paano nga ba ito ginagawa sa code? So, let's start with C. We'll start with thinking about this in C. Pa-move ng camera dun sa pointer.
Hindi ko lang kung makikita
Lalakihan ko.
sige.
Okay. So, how do we create this kaya in C? Ayun. So, let's look back at our initial data structures. Yung pinaka-fundamental data structures na meron tayo in C would be the array and the linked list. Diba? So, we need something that will allow us to easily insert items at the middle. Kasi yun yung property nung tree. So, yung nag-a-allow nung ganong klaseng insertion would be the linked list. Okay? So, pero, may magbabago. So, to create this linked list, ganito siya. We need to create a structure similar sa isang normal linked list. So, let's do that. Tapos, yung components niya would be yung data, definitely. Tapos, instead of having just one pointer, we'll have 2 pointers na. We need pointers to the left node and to the right node. Kasi yun yung property nung tree natin. So, let's create that left pointer and that right pointer. Okay? And that's it. Okay? This is how you create a node in the linked list data structure. So yung nodes natin is represented by this structure and yung edges natin is represented by the pointers. Okay? That's how to create a tree. Tapos, you have to create those functions on your own.